exponential equations. All right, we're going to start by solving this. 5 to the 3x minus 6 power equals 125. First thing we're going to do when we go to solve this is we are going to rewrite them so they have the same base. So the 5 is the lowest number that can be, so that's going to be 5 to the 3x minus 6. Well, 125 happens to be 5 to the third power. Once you get the bases the same with these exponential equations, you can just kind of drop them because it's like saying 5 to this power equals 5 to that power. So those two powers must equal each other. So 3x minus 6 equals 3. Solve for x. This is a very simple equation. Add the 6 across. We're going to have 3x equals 9. So x equals 3. And if you check it, it'll work out the same way. 3 times 3 is 9, minus 6 is 3. 5 to the third power equals 125. Okay. Example B is another example kind of similar to this. We're going to have 8 to the x plus 2 power equals 4 to the x minus 3 power. In this case, I know that I can rewrite the 8 and the 4 as powers of 2. So 8 is 2 to the third, and that's going to be to the x plus 2 power. 4 is 2 to the second, and that's going to be to the x minus 3 power. Here we use the power property. Power to a power, meaning you're going to multiply them. So it's going to be 2 to the 3, x plus 2, and of course we'll distribute that. And then 2 to the 2, and then x minus 3. And we'll distribute that as well. But once you get those bases the same, grab those exponents and put them equal to each other. So I'm going to distribute and put them equal together at the same time, just to save some time. 3x plus 6 is going to equal 2x minus 6. Move your x's, so subtract your 2x, subtract your 6. Okay, those guys cancel, those guys cancel. We're going to get x equals negative 12. Okay, so I didn't even use a calculator and just carry on from there. Now, if you can't rewrite the bases, then you have to use something else, another method to solve. So here is another example. I've got 5 to the x power equals 134. Okay, 134 cannot be rewritten as a power of 5, not with integers and all of that. So we have to use another method. In this case, you have to use a logarithm in order to solve this type of equation. So that's what we're going to do. Now, it doesn't matter if you use natural log or common log, but those are the two you want to stick with because you're going to use your calculator. So I'm going to use a natural log. So that just means I'm going to take the log of both sides. It's like another operation. The natural log of 5 to the x is going to equal the natural log of 134. You will get the same answer whether you use a natural log or a common log. Does not matter. So now with this right here, that x by the power property of logs is going to become a coefficient. So we're going to have x times the natural log of 5 equals the natural log of 134. Now, I'm not touching my calculator until I get x all by itself. I do know that the natural log of 5 is some crazy decimal, and the natural log of 134 is also a crazy decimal. I don't care what they are, the calculator's going to do it for me. At this point, I'm going to divide by the natural log of 5. That's going to give me x equals the natural log of 134 over the natural log of 5. At this point, I grab my trusty calculator and I'm going to enter it in there. One little tip, your calculator will open parentheses, so make sure you close them before you hit the divided by the natural log of 5. And you're going to get x is equal to about 3.04. Don't ever round these off to the whole number. Please take them out, as far as the directions say to. If they don't say, take them 3 or 4 decimal places. Okay, do not round them off too much. You round them off too much, you get in trouble. All right, D, another example. Here I've got 10 to the x equals 8,000. Now, I know I said in the last problem that it didn't matter what log you used, whether you use common log or natural log, but in this case, since I'm taking a 10 to the power of x, I want to use a common log, okay, because of those properties of common log. Common log is base 10. So when we take the log of both sides, okay, what was that property? When the base and this exponent are the same, look at that right there. What can I do? Oh, those are going to cancel out. Bye-bye. Leaving you with x equaling the log of 8,000. Put that into your handy-dandy calculator, and you're going to get about 3.9. So, there's those. The next example, I'm going to call example E. Here I've got 7e to the 2x power minus 5 equals 58. Okay. Now, since e is in this equation, what log do you think I'm going to use when it comes time to use a log? I'm going to use the natural log because the natural log is base e. Okay. But first, we need to get that e to the 2x power all by itself. So we're going to add the 5, 7e to the 2x, and that is an e. I know my handwriting is atrocious. Equals 63. Divide by 7. So e to the 2x power equals 9. At this point, we're going to use the natural log. I'm going to take the natural log of both sides. The natural log of e to the 2x equals the natural log of 9. Well, here is that special situation. Again, those guys cancel out. Bye-bye. Leaving you with 2x equals the natural log of 9. Divide by 2. And you get x equals approximately 1.10. Okay, the next example. Oh, I hope you've eaten your Wheaties for this one. This one's fun. Let's start this one up here. Here we've got 3 to the 2x minus 1 equals 7 to the x plus 1. I can't rewrite either of those, so they are of the same base. So here we're going to have to use a log. What log you use doesn't matter. These are base 3 and base 7. They're not base E or base 10, so it doesn't matter. Take a pick. I'm going to use natural log because it's ln versus log. I have to write one less letter. Literally, that's why. So natural log of 3 to the 2x minus 1 equals the natural log of 7 to the x plus 1. I'm going to use that power property of logs. I'm going to bring those powers and put them in front. So we're going to have 2x minus 1 times the natural log of 3 equals x plus 1 times the natural log of 7. Now I'm going to distribute the natural log of 3. The natural log of 3 and the natural log of 7 are crazy decimals. I don't care what those decimals are. I'm going to leave it looking like that until the very end. So we distribute. You're going to have 2x natural log of 3 minus the natural log of 3 equals x times the natural log of 7 plus the natural log of 7. Now, I have an x on both sides, so I want to get all my x's on one side of the equation and everything else. Again, natural log of 3 and natural log of 7 are numbers. They're just plain old numbers. Okay, so I'm going to subtract x natural log of 7, and I'm going to add natural log of 3. can't actually combine them. They're not like terms. So we're just going to have 2x natural log of 3 minus x natural log of 7 equals the natural log of 7 plus the natural log of 3. Now, I've got an x here and an x here. So my favorite F word is factor. So that's what we're going to do. We're going to factor that x. Okay, so x and then parentheses 2 natural log of 3 minus a natural log of 7. Oh, that's just a number. I can divide by that, right? Well, that's going to be our next step. Notice I'm not touching the calculator till the very end. So now I'm going to divide both sides by that 2 natural log of 3 minus the natural log of 7. And I've got x equals, oh my goodness, natural log of 7 plus the natural log of 3 divided by 2 natural log of 3 minus the natural log of 7. Now you notice I put parentheses around the entire numerator and the entire denominator. That's to help you when you're using your calculator, because that now is the time to grab that bad boy and use it, because this will be approximately 12.1 if you enter it into your calculator correctly. I have one more problem for you, one more example. Okay, this example might be a little scary also, but we can do it. We've got e to the 2x minus 8e to the x plus 7 equals 0. Now when I look at this, I get a little confused at first, going, holy moly, what am I going to do with this? And then I remember, oh, factor. It's like a quadratic. You're going to think I'm nuts, but that's all right. I'm going to go kind of quickly because I'm running short on time. This video is running a little long. Okay, then you factor and you solve each one. So I'm going to set each factor equal to 0. E to the x minus 7 equals 0. E to the x minus 1 equals 0. So e to the x equals 7 and e to the x equals 1. Well, that's easy. X equals 0. Okay? Anytime you get something to a power equaling 1, that power must be 0. Here we're going to use a natural log. Natural log, these guys cancel. You've got x equals the natural log of 7. For your decimal crazy people, 1.95. Hopefully you followed along with this. You can pause the video as you need to. And yes, I still have a little bit of time. So I'm going to stop it now. Woohoo! Have a good day.